we solved two numerical examples. The first numerical example was mainly on gravitational force. The second numerical example was mainly on the spring force. And now this final example that we will solve is mainly on the on how to deal with the friction forces here. So again, this is example problem 3 by 2, which is again taken from your tutorial sheet. And this is a problem in GL Medium book. So the 50 kilogram crate, which is this crate here, is stationary when the force P is applied. So this is stationary on this inclined plane, and the angle of the plane is given, which is 15 degrees. So determine the resulting acceleration of the crate, F P equals 0, P equal 150, and C P equal to 300. So you need to calculate the acceleration of the crate for all these P's. So this means that this question have three parts: part A, part B, and part C. Okay, so to solve this problem, again, you are given the mu s, which is the coefficient of static friction, which is 0.2. And then you are also given the coefficient of kinetic friction, which is 0.15. So this means that the as we discussed this already, that the coefficient of kinetic friction is always less than the coefficient of static friction. Okay, so to solve this problem, first we what we are told that the weight is given. So mass. Okay, so mass is 50 kg. Determine the resulting acceleration of the crate. So you need to calculate the A of this crate. And for three cases, the first case is P equal to 0. The second case is when P equal to 150 and newtons. And C is when P is equal to 300 Newton. And you're also given the coefficient of static friction, which is 0.2. And the coefficient of kinetic friction, which is mu k, is 0.15. So to solve this problem, you will need to draw the free body diagram for this case here. So to draw the free body diagram, we will. This is the body here, and the applied force is in this direction here. And we will assume that the acceleration is in this direction, ax, and we will assume that this is our x direction and this is our y direction here. So this is our coordinate system, and the mass is given, which is 50 kg, and this angle is also given, which is 15 degrees. Okay, so from here we can see that the weight of this crate should be in this direction here, in the vertical direction. So this is the weight. So you are given mass, so from mass you can calculate weight. Okay, so in this case, this W can be split into two components, one in this direction and one in this direction. And this angle is 15, so this angle is also 15, because these two lines are perpendicular to these two lines. So that's why this angle and this angle is the same. Okay, so now we can try to calculate the different forces here. Now the first force, if you want to calculate the mu, the maximum friction force, if you want to calculate, so we know that the equation for this is mu s into n. So now from this diagram we need to calculate the n. So n is the normal force, and its Again, a misconception that the students will always take this equal to mg, which is true when a body is lying on a horizontal surface. But for this specific case, when the body is on inclined plane, then n is not equal to mg. So you will need to properly calculate this force here. In this case, n will be in this direction here. So the normal force, which is a normal force on this block, and which should be perpendicular to the surface here. So if you want to calculate this n, okay, and again we know that this is our y, and this is our wx. Okay, so now obviously there is no motion in the in the y direction. So we can write that summation of all uh, the forces in y direction equal to ma of y, and ay is 0. So this means that this is equal to 0. So if we use this equation, we should be able to calculate n. So to use this equation, in the y direction, we have n, which is positive, and we are taking this is our positive. So n is positive here, and then you have wy, which is uh, minus in the minus direction. So 50g is the weight, and wy is adjacent to 15, so it should be equal to cos 15 equal to 0. So this will provide you n. So n will be equal to 473.78 Newton. So from here we are able to calculate n. So as you can see from this figure that in this case n is less than the weight, because the weight is w, and n is equal to wy. So n in this case is not equal to mg. Okay, and this is the exact value of the n that we managed to calculate from here. Now from this n we can calculate the maximum static friction force, which is F max. Okay, and we know the value of the mu s, which is 0.2, and we calculated n. So n is 473.78. So from here we will calculate this value, which will become 94.75 Newton. This is the maximum static friction force. Now this force is important because to move the body, the applied force on the crate should be greater than this force here. If it is not greater than this force, then the body will not move. So let's see our three different cases. So when the first case that we have is that when p equal to 0. So when p equal to 0, now we can calculate the net force on the crate. So because we know that this is our crate, so if this p equal to 0, and then in this case another force that we have on the crate is wx, which is in this direction here. And again we are taking here this is our y-axis, this is our x-axis, and again we are assuming that the acceleration is in this direction here. So this is the case. So in this case the net force on the block is wx. So if you calculate wx in this case, which will be equal to again 50g, and as you can see here, it's opposite to this angle. So it will be sine of 15. So from here you will be able to calculate this Wx, which is 126.95 Newton. So this means that the total force on this block in the downward direction is 126 because P is 0. So this means that this 126 is greater than 94, which is the maximum static friction force. So this means that the body will move in the downward direction. So this and once the body start to move in the downward direction, so this means that the body is moving, and when the body is moving, so then the actual force should be mu kn. So then we can apply this rule here: summation of all the forces in x direction equal to max. And again, we are taking all the forces in this direction is positive. Okay, and if in addition to wx, now if the body start to move, we will also have now fk, because the body is now moving. So the force should be fk, which is the kinetic friction force. Now because, and you can write this, that because now the body is moving, so therefore we have a kinetic friction force here. Okay, so now we are taking this is our positive x, so this means that the fk is in the positive direction. So fk is you can calculate is 0.15. So fk is equal to mu kn. So mu k is 0.15, and n is, you already know it, which is 473.78. And then you have wx, which is in the negative x direction, and which is 126.95. And then on the other side, we have max. So m is mass, which is 50, and ax is unknown. Okay, so in this case, this will provide us with a value of 118 meter per second square with a negative sign. So this means that we assume that the acceleration was in the upward direction, but because if you do all the calculation and it provide you with the exact value, so this means that the A, the body is in the downward direction. So this is the this is how you will deal with this case here. Okay, now we can solve the part B now. So in part B, what you are given is that when the force P is equal to 150 Newton. So when P equal to 150 Newton. Now first you need to calculate all the forces on the block. So if you just look into the block, so now you have P here, which is 150, and you have the Wx, which is in this direction, which is 126.95. Okay, and so again, from these two forces, you can calculate the resultant force in x direction. So this is our x direction here, and this is our y direction. So the resultant force in x direction, which is summation of all the forces in x direction, will be equal to 150, which is in the upward direction, and then minus 126.95. which is the weight of the body. So first we will calculate this resultant force on this crate. And if you do this calculation, what you will get 23.04. And we know that the F maximum in this case, which we calculated, was 94.75. This means that to start the motion, the net force should be greater than 94.75. But in this case, the net force on the block or on the crate is 23.05 only. This means that the applied force is less than the maximum friction force. This means that this force is not enough to start moving the body, and therefore the body will just stay stationary. So then you can write this, that the net force on crate is less than F max, which is maximum static friction force. Okay, so the body will not, yes, if the body will not move, so what will happen? The A x will be automatically equal to 0. So this is how you will solve this part of the problem. Okay, now if we see the part C here, so the part C is when P equal to 300 Newton. In this case, again, you will draw the free body diagram. Now, this force, which is P, is 300 in the upward direction, Newton. The Wx, which was in this direction, which is 126.95. Again, here we are using x and y coordinate system. And again, okay, so from these two forces now, the resultant force, so summation of all the forces in x direction, so one is 300 and one is 126.95. So first we need to find out that either the block is moving or not. So the net force on this block is 300 in the upward direction and 126.95 in the downward direction. So the net force in this case will be equal to 173.05 Newton. So this is the net force on this case. And obviously we know that the F max, which was the maximum static friction force, was 94.75 Newton. So this means that the applied force, the net resultant force on the crate, is greater than the maximum static friction force. This means that this force is enough to move the body. So the body will moving, and if the body start to move, so then we will have a friction force opposite to the body. But because the body is moving, so this will be Fk, which is mu k times n. So once the body move, then we will have the kinetic friction, not the static friction. So this is a really important point here. That the static friction, the maximum static friction force, is the force that you need to start the motion. But once the body start to move, then the actual friction force is kinetic friction force, which you will calculate from the mu kn. Okay, so now we can solve this problem now. And again, we are assuming that the body is moving, so the acceleration is in this direction here, ax. Again, we will just use summation of all the forces in x direction equal to max. Okay, so now in this case, we have three forces. One is the P, one is the Wx, and one is the Fk. So if you combine all these three forces together, so F, and we will again taking this is our positive direction. So 300 is the P, and then you have 126.95, and then you have the kinetic friction force, which is minus mu k, which is 0.15, and n is 473.78. So, and this should be equal to m, which is 50, and ax, which is unknown in this case. So if you calculate ax, that will become equal to 2.04 meter per second, and we get a positive value. So positive means that the assumed direction of the acceleration is correct. This means that the body, the crate, in the upward direction.